All right, Chapter 1, Classification of Matter. So, this is not exactly a full definition of matter, but it is a very good breakdown of what matter is. Okay. Remember, matter is anything that has mass and takes up space. So, that's right, focus. Okay, I need to write bigger. All right, matter is anything that has mass and takes up space. This is really when you start to get down to the most basic, the most fundamental juju of science. Mass is kind of the physical embodiment of inertia. You know, when you push on something, it's hard to move. The more mass it has, the harder it is to make it move. And it's also hard to make it stop moving. It's harder to make it change the direction of its motion. That's what inertia is. A thing will continue at the same velocity until you act on it with a force. Space, volume, that is a lot more difficult to work with, mostly because you can't pick up and play around with space. So you look that up on Wikipedia, you're going to get a great big, confusing, long article. It's something that physicists and philosophers both worry about a heck of a lot. They do a lot of work on that. Continuing, we have pure substances on the left versus mixtures on the right. So matter's divided into those two. Okay, matter can either be a pure substance or a mixture. Now, a substance is kind of a catch-all term. So in chemistry, a substance is just a single kind of stuff. It is something that has a uniform set of physical and chemical properties. And it will always be the same for those properties from one sample of that substance to another sample. Now, a mixture is a combination of two or more substances. And the thing about a mixture is that those substances can come in any sort of ratio or combination. So, for example, water is a pure substance, and water is always going to be H2O, which will always have two atoms of hydrogen to one atom of oxygen, no matter what. It will always be that when you have H2O. But salt water is going to be a mixture of the two substances of hydrogen, dihydrogen monoxide and sodium chloride, table salt. Okay. Each one of these is a pure substance. You mix them together, you get a mixture. And you can have a wide variety of different kinds of salt water. You can have a very small or almost indetectable amount of salt in your water, or you can have a huge amount of salt in that water. And you can have any sort of variety in between. So that's one of the things that distinguishes a mixture. I'm blanking on the word I'm looking for. Well, let's just go with constitution. A mixture is distinguished from a substance in that the two or more substances composing the mixture can have a continuously variable amount. So For example, that salt water on the left, you can go from pure water with 0% sodium chloride to something like 510 grams per liter of sodium chloride. That is a measure of concentration. Grams of sodium chloride per liter of water. I'm kind of making that number up. I don't know exactly what it is. I'm now thinking it might be closer to 310. Doesn't really matter. The point is, salt is very, very soluble in water. It's easy to dissolve. And it can be anywhere in between. That's what I mean by continuously variable. Okay, that there's no discrete steps. It can be anything along that scale. And constitution, I just mean that those are the things that constitute it, that make it up. So that is what defines, what distinguishes a mixture from a pure substance. A pure substance, if there's more than one kind, no, we'll get into that, will always have a particular ratio. A mixture will have a variable ratio. So, substances and mixtures are further subdivided into different types, different varieties. Now, a pure substance can either be an element or a compound. Now, elements are the building blocks of the universe. Hold on a second. Just bringing up this periodic table here. This is a periodic table of the elements. We're going to go into plenty of detail on what this is and how you can read it. But for now, just note that it is a lot of different elements. The elements are the building blocks of matter. This is a particularly nice periodic table. It is ptable.com. And you can play around with it. You can change the temperature. That will give you the different states of matter for all the elements at different temperatures. So you can see at room temperature, or 273-ish. Let's change that manually. What are you doing? Don't do that. All right. You can see that most of the matter in the universe is going to be a solid. That's the black. You have the two liquid elements at room temperature, and then you have a handful of gases. Those are the red. Okay. You also get the variations. You have the non-metals in bright green. You have the metalloids in this darker green. You have the post-transition metals in this teal-ish color. I don't know. You have the noble gases over here in this light blue. You have a lot of transition metals, as they're called, in this sort of mauvey pink. Then down here you have the lanthanoids and the actinoids. And then you have the alkaline earth metals and the alkali metals. And then you have hydrogen being over here, kind of a weird beard. It sometimes counts as a metal, sometimes counts as a non-metal, depending on what you're looking at. It's the lightest element in the universe, the smallest, and it is always going to be a little bit weird. But these are all the elements. The thing about elements is that they cannot be broken down chemically. Chemical processes will change one substance into another substance by either combining or decomposing elements, or switching out one set of elements for another. So let's go ahead and go back to this. All right. So those are the elements in the compounds. These are things that can only be, gone back and forth between using chemical processes. Apologizing for the slow transitions, but I'm using my left hand to manage the mouse, so I have my right hand free over here. This is a slightly awkward setup. I'm doing the best I can. All right, so So elements are the purest of the substances. They cannot be made simpler using chemical processes. But a compound A compound is made of two or more elements. Okay? So, for example, water is a compound with the elements hydrogen and oxygen. Table salt is a compound of sodium and chlorine. Sugar is a compound of carbon, hydrogen, and oxygen. Okay? So compounds can get very, very complicated, especially when we're talking about organic materials like sugar. Organic meaning necessary for life and almost always involving carbon. Okay? And it's important to note that compounds can only be broken down chemically. That is to say, not physically. Okay? We'll get more into chemical versus physical in a bit. But just remember that distinction for the moment. Okay? So now back to mixtures. Mixtures are also divided into two separate categories, probably just for the symmetry of the thing. Mixtures are divided into homogeneous and heterogeneous. Okay? Homo is Greek for same, hetero is Greek for different, and here geneus is referring to genre or type or kind. So a homogeneous mixture versus a heterogeneous mixture. We're looking at phases. So a homogeneous mixture has one phase. So salt water, again, is a homogeneous mixture. If you look at it, every single part of the mixture is in a single phase. No part of the mixture looks any different from any other part of the mixture. Whereas if you look at a heterogeneous mixture, you're looking at something with multiple phases. You can distinguish different portions of the mixture. So a salad would be an example of a heterogeneous mixture. Water with dirt in it would be another example of a heterogeneous mixture. Two or more physically distinct phases, but they're still mixed together, muddled together. So those are the two different kinds of homogeneous or the two different kinds of mixture, homogeneous and heterogeneous. Now, a mixture of any kind, homogeneous or heterogeneous, can be broken down physically. A compound can only be broken down chemically. Okay. So that is one of the big ways of distinguishing between pure substances and mixtures. And what is a physical separation? That could be as simple as just picking the tomatoes out of your salad, right? Because raw tomato is gross, and if you like it, you're wrong. Okay. But it could be, more complex, more difficult. Like if you want to get salt out of water, you have to boil off the water. If you want to break down a compound, on the other hand, you have to use chemical methods. Now, chemical processes can look very similar to physical processes. Heat will often be involved in both, right? Boiling water. But that doesn't mean, but when you look at the difference, when you really get down to it, a chemical process will involve a change in substance. A physical process will only result in either a change of phase or a separation of substances, but it won't involve one substance turning into another. All right, that does it for Lecture 1. We will continue, hello puppy dog, in a bit with Lecture 2.